Hiya folks, this is question 7. So, when it rains on land, some of the rain soaks into the land, the rest runs off the land. The runoff curve number C is a number used when estimating the amount of rain that runs off a particular area of land. So C is given by, so C is the amount of water that runs off. So it's given by 1000 over S plus 10, where S is a measure of the maximum amount of rain that can soak into the soil. So find the value of C when S is 15. So first part, you just have to sub in 15 in for S. And when you do that, you can go straight to the calculator and you should get 40. So second part, when S increases, does C increase or decrease? So when S increases, then the number on the bottom of the fraction has to be going up all the time. So it'll decrease. So if you think about it, if you have 1 over 2, but then if you had 1 over 3, that even though 3 is a bigger number than 2, the size of the whole thing is smaller now, because a third is less than a half. A third is smaller than a half. So when the number on the bottom of a fraction goes up, then the whole thing will actually get smaller. So 1/4 is less again, 1/5 is less again, 1/6 is less again, 1/7 is less again. So the higher the number on the bottom of a fraction, then the lower and lower it gets. So that's the reason. So number divided into 1000 is getting bigger. So you need to say something like that. Rearrange the equation to write S in terms of C. So C is 1000 over S plus 10. Right, so you have to rearrange it around. So first of all, the only thing you can really do with it is multiply by what's on the bottom. Whenever you have a fraction in an equation, then to get rid of the fraction, you always multiply both sides by what's on the bottom. So that's what I'm going to do. I'm just going to multiply both sides by what's on the bottom. So on the left hand side, I'm going to do C multiplied by S plus 10. So it has to be by all of it. Equals, on the right hand side, if I multiply that by S plus 10, it cancels out with the bottom, so the bottom is gone. So you're left with this then. So I've got CS plus 10C when I multiply out the brackets. They're S's, look a little bit like 5's. That's a C, equal 1000 still. I need to get S in terms of C, so I just need to get S equals. So I need to get everything else to the other side. So I'm going to move over to 10C first of all. So 1000 minus 10C. And then I'm going to move over the S and divide it. So C is equal to, is that right? No, it's the other way. It's the S I'm trying to get. Yeah, right, S in terms of C. So S is equal to 1000 minus 10C all over C. And that's it. So the values of C go from 30 to 100. So use your answer from before to find the range of values of S. Right, so all we have to do here is we're going to take the equation we just had, and I'm going to put in 30 for C, and I'm going to put in 100 for C, and that's all we're going to do. So if you're putting 30 for C, you get S equals 1000 minus 10 times 30 all over 30. And then you can put all that in the calculator together and you should get 23.3 recurring. The other one, so S equals 1000 minus 10 times 100. I'm putting in 100 now, all over 100, and you'll get 0 there. So equals 0. So from 0 to 23.333 recurring. So the values of C go from 30 to 100. So if the values of C go from 30 to 100, then the range for S has to be, the biggest one is going to be for 30, and then the smallest one is going to be for 100, because remember we said before that the bigger the number C is, the smaller S will be in this case as well, because you're dividing in. Right, write down the probability. So over the course of 24 days, the probability that it's raining in Waterville could be modeled by that function. So T is the hours after the start of the day. So we have to write down the probability. So yeah, so this first one here, P of 0, that'll work out for 0 hours after the start of the day. So that's right in the morning. And then P of 24 tells us there in the sentence anyway, that'll be after 24 hours after the start of the day. So that's the end of the day. So P is 0. You're just going to sub in 0 onto this. So 0.3 plus 0.02 multiplied by 0. And you don't even need calculator there. You can see that it's going to be 0.02 multiplied by 0 is just 0. So you're just left with 0.3. P of 24. So 0.3 plus 0.02 multiplied by 24. And if you put that in the calculator, you should get 0.78. And that's it. That's all you have to do for the first part. Find the value of P dash T, so the derivative of T, so we have to differentiate T here. So P of T is 0.3 plus 0.02T, so it'll be quite simple. P dash T, because 0.3 is a constant, so same as just because the decimal is still a constant, it means it's gone. When then the other one we reduce down the power, well, we do 1 multiplied by 0.02 and then reduce down the power, so we're just left with 0.02 here. And then they ask us for the meaning of P dash T. So it'll always be rate of something anyway when it's differentiating. So it's the rate of the probability of the rainfall increasing per hour throughout the day. So something like that. At a certain time, the probability that it's raining according to this model is 0.35. Work out the probability that it is raining exactly 1 hour later according to this model. Right, so for this one, they're basically giving us the answer to that 0.3 plus 0.02t. So we know P of t is 0.3 plus 0.02t. So we know that that the answer to that will be 0.35 because that's how much rainfall it is at a particular time, but we don't know the time, so we have to work out what the time is. So if you move over the 0.3 to the other side and subtract it, it's the same as algebra, just rules of algebra now. We get 0.05 is equal to 0.02t, and then if we just divide the 0.02 in, so just using the calculator, what did we get? Yeah, you get 2.5. So 2.5, so that's 2.5 hours. So what you've just worked out there is it's 2.5 hours. At 2.5 hours, there was 0.35 of rainfall, whatever it's measured in. So that's how much rainfall at 2.5 hours. So, or no, sorry, it's probability of rainfall at 2.5 hours. So what you're asking the question is, what's the probability that it is raining exactly 1 hour later? So 1 hour later would be 3.5 hours. So therefore I'm going to put that straight into the function, and that'll be it then. So we just have to work out p of 3.5 because that's 1 hour later after 2.5 hours. So 0.3 plus 0.02 multiplied by 3.5, and then you can use your calculator again, and you should get 0.37. So that's it then. That's all for that question.